cloning the Goof repository to your local environment. If you list out its contents, we can see that Goof is a JavaScript application, and it is packaged into a container by means of the Docker file. If we look at the Docker file to understand what's going on as we build this container, we are starting off with a Node 10.4 base image, copying in our application, updating npm, installing its dependencies, and finally when our container starts, its entry point is to actually start the Goof application itself. So to start, we'll first package Goof into a container using the docker build command. Now, it's worth noting that for this demonstration, in the repository settings, we have enabled Docker Hub's vulnerability scanner. What this does is whenever a new image tag is pushed to this repository, it'll be scanned using the Snyk vulnerability scanner. We can see that the latest tag that we just pushed has 451 high severity vulnerabilities, 484 mediums, and 20 lows. We can dig into the details of the vulnerabilities by clicking on the high level issue counts, the package that introduced it, as well as its version, and then, if available, the version of the package in which this vulnerability was fixed. Now, starting off with 955 vulnerabilities is a lot of work, so we can use the docker scan command built into Docker Desktop to scan images for vulnerabilities before we push them to Docker Hub. As well as get recommendations on potentially more secure starting points in the form of a more secure base image. Let's see what that looks like. To scan an image for vulnerabilities using Docker Desktop, simply type docker scan and pass in the name of the image that you'd like to scan, as well as the Docker file used to build the image. It's worth noting that passing the Docker file is optional. Once the vulnerability scan completes, we can see information about the individual vulnerabilities found right in the docker scan command's output. These are the same vulnerabilities available in the Docker Hub web user interface. And because we passed in the Docker file, we see that the vulnerability scanner is actually recommending other base images that might be better starting points with less vulnerabilities. Since we have vulnerability scanning enabled in our repository, the Snyk vulnerability scanner will scan it as soon as it gets pushed, and we should see the image scan results shortly. We can see at a very high level that our v2 tag is significantly more secure than the previously uploaded latest tag. With this, we can now kick off our regular integration unit. So navigating to the images section in Docker Desktop and browsing the remote repositories, we can see the exact same vulnerability scans information within Docker Desktop. That way, as a developer, we can stay in the know about the vulnerability posture of the images that might potentially be running in production.